Hi everyone! Today we're going to learn about metamorphic rocks. We're going to learn about how they form and a little bit about how to identify the main types of metamorphic rocks. So to get started, we're going to look at a rock that we've seen before. The rock at the top of your screen right now is granite, which is a felsic composition coarse-grained rock. We can see the nice large crystals, we can see lots of pink feldspar in there. What happened at the bottom? If we take a look at the rock at the bottom of the screen, it looks very similar in terms of mineral composition to the granite, except it looks like all of those minerals have been squeezed out and squashed into a whole bunch of layers, which is actually called, what we'll learn today, foliation. What happened is this piece of granite literally did get squashed by a lot of pressure and a lot of heat, and it got turned into a metamorphic rock. That's what we're talking about today. So a metamorphic rock is when you have an existing rock that changes into something different through heat and pressure. The rock doesn't melt. That's really important when it comes to metamorphic rocks. If the rock melts, it turns back into magma and has to recrystallize. That makes it an igneous rock, not a metamorphic rock. There are different types of metamorphism. You can have something called regional metamorphism. And that's when you have lots and lots of pressure exerted because of plate tectonics. So maybe you have a mountain building region where you have huge amounts of pressure, huge amounts of temperature, and that can lead to metamorphism, rocks turning into metamorphic rock. You can also have something called contact metamorphism. If you have an igneous intrusion where you have a large pocket of magma surrounded by existing rock, that magma is obviously very hot. And so that's going to increase the possibility of metamorphism in the surrounding rock. Remember, the surrounding rock can't melt, it's just going to transform into something else through this immense heat and pressure. Finally, you can have something called hydrothermal metamorphism, where high temperature water gets passed through a rock outcrop. That high temperature water has a lot of dissolved ions in it, and that can lead to great temperature and pressure as well. So metamorphic rocks are described based on, one, their level of metamorphism, which means how much temperature, how much pressure was exerted on this rock, and two, whether they are foliated or non-foliated. Foliated, by the way, means layering. Now, one thing that can give us a hint as to the amount of temperature and pressure exerted on a particular rock is what minerals are present. Because as the temperature and pressure of a rock change, the minerals in the rock will also change. They undergo what's called a solid state alteration. That means the minerals are changing without melting. They're solids all the time. Texture of metamorphic rock is also really important. Remember how I mentioned foliated versus non-foliated? This gives you a really big hint as to what type of metamorphic rock we're talking about. Foliated rocks occur when needle-like minerals line up, when they're squashed by great pressure. So you can have all of these nice little layers. Sometimes they look like stripes. That's called foliation. A non-foliated rock is made up of minerals that don't line up so nicely in little needle-like shapes. They're kind of blocky and chunky, so they're not going to form stripes. They're not going to form layers when temperature and pressure are exerted on that rock. Here's an example of a foliated rock. In the picture on the left, you can almost imagine those needle-like shaped minerals lining up as great pressure is exerted. We can even tell the direction of the pressure. In this case, the pressure would be exerted in the downward direction, causing all those minerals to line up left to right. Picture on the right, you can see really, really clear stripes where certain minerals have lined themselves up with similar minerals, creating this stripy effect. At the bottom, we've got our non-foliated rocks. You can see, especially with the zoomed in image on the left, really chunky, blocky minerals that aren't going to be squashed in this needle-like way. So it's not going to form stripes or layers. Here are the different types of foliated metamorphic rock, and they're organized on this page based on how much temperature and pressure was exerted on them. The first thing we're going to start with is slate. So slate has very, very fine grain size. If you look at slate from the side on, you're going to see some very distinct layers. And this particular rock came from shale. So shale had great pressure exerted on it but not as much as some of the rocks we're going to talk about down below, but great pressure exerted on it, turned into a metamorphic rock, and that metamorphic rock is slate. Here's an example of slate. It looks a lot like shale, and in this particular example, it's very hard to see the layering going on, but it is there. Slate, you may recognize, used to be used as a chalkboard a long time ago. People can also have slate roofs. Here's another sample of slate. Notice how there are some nice layers that you can see. Slate tends to be a little bit harder than shale. Remember, shale broke very, very easily because it was so poorly cemented. Slate is a little bit stronger than shale. Now, if we take slate and we have it experience intense pressure and temperature, it's going to turn into another type of metamorphic rock. This metamorphic rock is called phyllite. So a little bit more metamorphism, and we've got phyllite. Phyllite also is made up of a fine grain size. The parent rock is slate. The only example of phyllite that I have is a very, very, very teeny tiny example. But if you look edge on, which is hard to see on the camera, you should be able to see some clear layers that are going on, some clear foliation. You're also going to notice how lustrous it is. It is quite a bit more lustrous than slate is. It's typically made up of a lot of mica, and mica is a nice lustrous mineral, vitreous luster. Now we're going to take that phyllite, we're going to exert even more temperature and pressure, and we're going to turn it into the next grade of metamorphic rock, and that is called schist. So this is a medium to coarse grained rock. Yes, it is also composed of a lot of mica, and in this kind of a rock, you're going to actually see flecks of mica, and the mica can also flake off sometimes too. Here's a really nice mica schist. Notice how sparkly it is, how lustrous. You can actually see the flecks of mica in it. You can also very, very clearly see the foliation, those layers sandwiched together. Finally, we're going to take the schist. We're going to metamorphose it even more. I don't know if that's a verb. And we're going to turn it into gneiss, spelled G-N-E-I-S-S. So this one has very, very clear layering, very clear foliation. Here's an example of a nice granite. Gneiss. See lots of pink feldspar in there. In gneiss, we have very clear layers that are typically light and dark and light and dark, so the foliation is extremely obvious. Gneiss can also be formed from granite. Here's another good example. Notice the very, very obvious layering and foliation. Light, dark, light, dark. Here's a large outcrop of gneiss, and you can see someone beside it to scale. The last type of foliated rock we're going to talk about is migmatite, which I like to think of as, oops, it melted a little bit. It's basically gneiss that melted a little bit, but not totally. So it looks like it has foliation, but it's all looking a little bit mixed together and melty. Grain size is typically medium to coarse. Now we're going to talk about some non-foliated metamorphic rock. We're going to start with quartzite. Quartzite has a medium grain size, and the parent rock was actually sandstone. So you can imagine it's made almost completely of quartz. Here's a sample that I have of quartzite. It looks fairly generic. You're not going to see any foliation. If you looked really, really closely with a magnifying glass, you'll probably be able to see some nice blocky crystals of quartz. So the composition is almost entirely quartz. You may recognize this material because it's often used as countertops. The next non-foliated rock is something you have definitely seen before. It's marble. Marble is metamorphosed limestone or dolostone, so it's largely composed of calcium carbonate. It has a medium grain size as well. Here's a nice chunk of marble. The grain size is quite large in this one. Marble doesn't have to come in white colors, it can come in other colors as well. It's often used as a building material or for statues. Here's a fun sample that I have. This one's actually green because it contains serpentine. So it's marble, but it contains the mineral serpentine, which is a green mineral. Next up is coal. You'll remember that coal is also a sedimentary rock. That rock was called bituminous coal. When you metamorphose that type of coal, you squeeze out a lot of the oxygen, a lot of the other chemicals, so that you're left with mostly just carbon. This is now called anthracite coal. It's a little bit more shiny, a little bit more lustrous than bituminous coal. Here's a sample of anthracite coal. See how lustrous it is? So that's mostly just carbon, squeezed under intense temperature and pressure. The next type of metamorphic rock is called hornfels, which is a generic, dense, usually black or dark gray colored rock. It's pretty fine grained, so you're not going to see any grain size, you're not going to see any foliation, and it can literally be made out of almost any rock or mineral. So this is just hornfels. The last non-foliated rock we're going to talk about is soapstone. If you've ever done soapstone carving, then you've experienced soapstone before. Soapstone is just metamorphosed talc. It's very soft, it's very fine-grained. And one thing I wish you could tell, which you can't tell through video, is how soft it is. Soapstone is very, very, very smooth and soft because it's so fine-grained. This one has some cool dendritic features, and that's just an artifact of how it was formed. They don't all have these patterns on them. One interesting feature of some metamorphic rocks are the ability of certain minerals within the rock to recrystallize. So you can grow from a solid state to a solid state. You can grow minerals within this fine-grained matrix of the metamorphic rock. The best example of this is a type of schist called a garnet mica schist. And this is something that we actually saw in class. When I was showing you examples of garnet, I showed you a very small piece of garnet mica schist. Here's that garnet mica schist right now. I'm not sure if you can see through the camera. The garnets are very well formed. They're actually called porphyroblasts. It's a fun word. And if you look really closely, you might be able to see the fine-grained matrix, which is actually a schist. So it has some nice foliation, very subtle but nice foliation. Now, many of these rocks you've probably heard of before. If you can think off the top of your head right now, which ones that you just heard about do you think are used mostly in construction materials? Well, if you think about it, you've probably seen marble buildings or marble statues. So marble is a construction material. Again, it's composed of calcium carbonate, so it doesn't like acid rain. And slate roofs, you'll find on some fancy buildings, maybe some old buildings. The one type of metamorphic rock we talked about today that produces energy is anthracite coal. Not a great thing to burn for the environment, but it definitely is used for energy production. Another interesting feature of metamorphic rocks. Many metal ores develop in hydrothermal veins. Remember, hydrothermal metamorphism is one type of metamorphism. So here's a nice picture of a gold quartz vein. I have a fun rock here, which is just hanging out in my house, which is made up of a variety of metals. And likely there's some quartz in there as well. It's pretty cool looking when you see it up close. So now we've gone through the whole rock cycle. We started with magma, which is this slushy of minerals and gases and dissolved ions, crystallizes into igneous rock. Igneous rock can be under great temperature and pressure and turned into metamorphic rock, or can be weathered and then eroded, deposited, turned into sedimentary rock. The sedimentary rock can be compacted, exerted to great pressure and temperature to turn into metamorphic rock, or any of the above rocks can just be melted back into magma and recrystallized into igneous rock. So it's a whole cycle that goes over and over and over. What you're going to do now is you're going to fill out your metamorphic identification guide. Because you unfortunately can't actually touch the samples today, you're going to have to use this video, the lesson that is posted, and you can also use the link that I've put on the screen, geology.com. It's a great resource, a lot of really amazing pictures and explanations of each of the rocks. For homework, here are the things you're going to do. You're going to create your own graphic, so not my crappy one in Smart Notebook. You're going to create your own graphic of the rock cycle that makes sense to you. Based on the rocks that you've identified so far, that's igneous, sedimentary, and metamorphic, you're going to list the rocks that are easy to confuse. So for identification purposes, which ones are going to be easy to confuse? I'll give you a hint. Slate and shale are really easy to confuse. And you're going to create a quick little guide that'll help you tell them apart. The other thing you're going to do is you're going to identify some of these metamorphic rocks on the SmartNote. The first one you're going to identify is right here, sample A. Sample B. Sample C. Sample D. Sample E, which is actually a rock outcrop of this type of metamorphic rock. Sample F, which is a famous statue you may recognize. And finally, sample G. That's it for today.